Okay, and now we are live sa ating Facebook page. Yes, and let's discuss this lesson, mechanisms of heat transfer. So just like what I've mentioned kanina, wala itong solving na part. It talks about lang the concepts, no, the conceptual part. What are the different ways on transferring heat? Yeah, mechanism of heat transfer. So let's start, no, with this concept. So, have you ever thought no, about how we feel heat? Of course naman, no, nakatry di ba mo ana inyong kamot ibutang niyo sa init or sa kandila, di ba? Of course, you can feel the heat, di ba? We easily feel heat when we accidentally touch the flame of candle. Have you ever tried that one? I know it's dangerous. No, it's very dangerous. Like, manay kandila anak ni mo kamot. Out of curiosity kasi, yeah, even ako when when I was a child, no, out of curiosity, I am fan of ano yung finger ko sa candle, no. Of course, init man, so bata pa man ko ato, so init, of course, um curious lang pud ko. So, maka-feel ta og heat unless manhid mo. Charot lang. Also, we notice also that the water still gets hot even though it is in the container and there is indirect contact, no? It's indirect contact with the flame. Kanang magluto kayo ng magluto, right? Magluto. So, if ever magluto kayo sa may mainit na apoy, then of course, nagluto mo kanon dira, try to touch the caldero, di ba? There is a heat transfer between your caldero to your kamot, even though indirect siya towards the flame. It doesn't have a direct contact, no, with the flame. And also, when your mother or atiba or papa is cooking, we can sometimes feel also the warm air from the kitchen within the whole house. So these situations occur, it's because the particles of the objects on fire or near fire vibrate faster, okay? Vibrate faster and transfer energy from one particle to another. So their behavior changes once they absorb thermal energy. And that's the time the overall temperature that surrounds the overall temperature of the surrounding or the object starts increasing. So in this lesson, you have the idea naman already, the difference between the heat at saka temperature. So, hindi na kayo mahihirapan, no? Na mag-deal with this lesson, because in this topic, mechanism of heat transfer, we will talk about how heat transfers from one object to another and also the applications in real life. Yeah. So how does heat flow from a very hot cup of coffee to your bare hand when you try to hold it? Also, how does the water inside the kettle attain a uniform temperature and starts boiling when only the bottom part is near the heat source? Ano kaya? And also, why can you still feel the warmth of the sun here on Earth even though the distance between the Earth at saka sun is sobrang layo? Yeah, we will try to answer these questions. The previous questions kanina in this topic. So the learning objectives in this lesson, first, recognize the different mechanisms of heat transfer. Yes, there are three mechanisms, no? Three different mechanisms of heat transfers. And explain how the heat is being transferred by conduction, convection, and radiation. So by the way, these three are the different mechanisms of heat transfer: conduction, convection, and radiation. Previously, we have defined heat. Class, heat is essential in our lives. It makes us warm when we feel cold. Also, it helps us cook our daily meals. And we also use heat not to dry and iron our clothes. And heat also is essential in appliances that we use daily, such as stove, air conditioner, kanang sige anak, heater, heater. So in this lesson, let's have defined heat in physics and the different methods of heat transfers and their applications. So we always associate the word heat with feeling hot or where there is an increase in temperature. Diba? Makadungog bug heat ay init. Diba? Mainom mog heat init. So again, heat is defined as the transfer of energy. Transfer of energy from one object to another or from the specific system to the environment or vice versa. It is due to the difference in temperature. Again, it is because of the difference in temperature. So when a kettle full of water is placed near a heat source, it would be incorrect to say that more heat is present in water. But instead, we can say that the kettle of water has more thermal energy which was transferred by heat. Okay, again it is wrong to say that the more heat is present in water, but the proper way of interpreting or saying is that the kettle of water has more thermal energy which was transferred by heat. So kanina, we have defined also heat as the spontaneously transfer from a hotter object to a colder one and stops the object when reach a common temperature or a thermal equilibrium. So in a bonfire, yeah, but in a bonfire, the thermal energy from the flame is transferred to the colder surroundings by heat. And yeah, diba? The thermal energy from the flame is transferred to the colder surroundings by heat, which is the reason why also we can still feel its warmth. I mean, kainit ba? We can still feel its warmth even if we are not directly on it. And this transfer of energy will continue as long as there is a temperature difference. Remember that the energy is being transferred by the heat is what we call thermal energy, and it is related to kinetic energy of the particles within an object or a substance associated with temperature. Again, let's differentiate heat. No, again, let's differentiate heat and temperature. So heat and temperature are related to each other, but they are two different quantities. So again, kanina, we defined heat as the transfer of energy from the system to the environment when there is a difference in temperature. Take note that the SI unit for heat is not Kelvin, but it's Joule. Again, the SI unit for heat is Joule. Ano, sir? Because note heat is being transferred, no? That is thermal energy. Diba? That's kinetic energy related to kinetic energy. Kinetic energy, the unit is joules. So heat, the SI unit for heat is joule. Meanwhile, temperature is the one that describes, the description that describes the hotness or coldness of the system or environment quantitatively. And temperature uses different scales to describe its hotness and coldness. We have the Celsius, the Fahrenheit, and Kelvin. But the SI unit of temperature is Kelvin. Temperature defines the unit of quantity of heat. Again, take note, temperature defines the unit of quantity of heat that is transferred in the system. And we use an instrument called thermometer to determine the temperature of a system. Now, let me present to you the three various mechanisms of heat transfer. First, we have conduction. Okay, conduction. Now, in your laboratory in chemistry, no? Example lang tayo. Suppose you are in laboratory holding a metal tongue with a test tube attached to its end. While the test tube is placed on the top of Bunsen burner, of course, what would you feel when you are already heating it for about 2 minutes? Diba? The metal tongues will eventually become hot because it's metal. Take note that metals can efficiently conduct heat. Again, metals efficiently conduct heat. So from that situation, we can say that the heat is conducted from a hotter object to colder one. Again, the heat is conducted from a hotter object through the flame to the colder one, which is the metal tongues. Anong magsunog-sunog mo? Lain po kaayo no nga, iinit ninyo ang test tube, dili mo magamit og metal tongs, masunog mo. Of course, you need to use metal tongs for safety purposes. Para mo mapasok. And kung mag-try na mo sunog sa test tube, di ba, maka-feel mo init. Okay? At first, bugnaw pa ang test tube. But because of the direct contact of heat towards the metal tongue, sa test tube, so manginit po ang metal tongue. Now, let's discuss conduction. When we say conduction of heat occurs due to the collision of the particles in object placed near a heat source. So once the particles of any object are subjected to heat, they will move rapidly, increasing their kinetic energy in the process. And due to the increase in kinetic energy, they tend to collide and transfer some of the other kinetic energy to the other particles. Then it will continue the process until the kinetic energy of the particles is being transferred within the whole object. Just like this one. Okay, it's like this figure. The figure shows that an object with varying temperature on both ends, so heat from the section with a high temperature flows to the end of the object with a lower temperature. As you can see in the given figure, the particles of the object with higher temperature starts to move faster or to move fast and collide with each other and continue to do so until both sections have equal temperature. By the way, this figure is the conduction of heat in an object due to temperature difference. So remember this one, according to the kinetic molecular theory of matter, the kinetic energy of a substance varies with temperature. When the substance has high temperature, it will have a high kinetic energy. And when it has low temperature, it will have low kinetic energy. This one, according to the kinetic molecular theory of matter. Let's discuss good conductors of heat at saka the insulators. So good conductors, we have the metals, no? Yeah, metals are considered as good conductors of heat. So Good conductors have free electrons that collide with other atoms or molecules throughout the metal. Meanwhile, insulators have tightly bound electrons, limiting their ability to move and transfer kinetic energy to the other neighboring atoms. So the in your chemistry na lesson, the atomic structure of an object, it determines how well an object conducts heat. Example, solids with free electrons conduct heat well. Again, solids with free electrons conduct heat well. So these electrons are free to move, and they are due to the free movement, it will collide with other atoms or molecules throughout the metal. If you can still recall, what are the excellent conductors of heat and electricity? Naman, what are the excellent conductors of heat and electricity? So makarecall sa inyong chemistry, huwag mo discuss ana. Tatlo ang ako ma-remember. We have the tatlo, gold, silver, and copper. Okay, gold, silver, and copper. I don't know the exact value of the conductivity, I forgot the value, but si silver na siguro pinahada ko, si gold. Dili ko sure nakalimot ko, dili ko sure. Pero sa electricity, si copper ang ginagamit. Okay, what's the reason why nganong sa electricity si copper ang ginagamit, dili si gold o silver? What's the main reason? Of course, again, excellent conductor of electricity, si gold, si copper, o si silver. Yeah, they're excellent conductors of heat and electricity. But what is the main reason nganong si copper ang gipili sa mga electric cooperative? Okay, anong si copper man dyan ang gigamit? Anyone? Do you have any idea? Ano kaya? Wala may problema. They are conductive. I mean, they're good conductors. They're excellent conductors rather. Okay? Anong si copper man ang ipili? Malamang barato man ang copper kaysa sa silver o gold. Sige daw be, kung gamit mo wirings na gold o silver, kasi pagtuon ninyo, dili na kawaton? Of course, cheaper, less price ang copper compared to gold and silver. That is why copper ang ginagamit sa mga electric cooperative. Okay? It's gamay lang man ang difference ng conductivity ng copper, silver at saka gold. But again, for business purposes, I mean, mas makatipid man sila pag mogamit sila copper. Kung sa Bisaya pa bronze. So sa Bisaya pa bronze, mas makatipid sila mogamit og copper kaysa sa gold o silver. Okay, again, kawaton, mahal biya ang gold o silver. Okay? That's one of the main reasons, nganong copper ang ginagamit. Now, kung ang copper o ang silver at saka gold are excellent conductors of heat and electricity, how about mga insulators? These insulators are what we call poor conductors. Again, insulators are what we call poor conductors. What are the examples of insulators? Okay, if that's correct, very good. It's wood. Another. Plastic, that's correct. Rubber. Okay, so wood, plastic, rubber, styrofoam, okay, they are considered as insulators. Okay, they are considered as insulators or poor conductors. That is why also, kung mapansin ninyo class, kanagong namoy electrical tape, di ba? Electrical tape is plastic in nature. It's rubber, di ba? Okay, because that's one way of preventing na mo penetrate ang electricity, di ba? So of course, kung maggamit sa electrical tape, dili siya makakuryente. Kasi electrical tape for instance is insulator siya. So insulators have a tightly bound electrons they limit their ability to move and transfer kinetic energy to other neighboring atoms. So because of this characteristic, insulators are commonly used as handles for cookware. Again, insulators are commonly used as handles for cookware. Of course naman, pag meron insulator or kanang rubberized na, no, dili kay maka-feel og heat, no, because again, insulators are poor conductors. So what are examples, no? No, yan. Metals such as silver, copper are excellent conductors of heat. Wood, plastic, rubber, and styrofoam are considered as insulators. Examples of conduction. So when you touch the flame of lighted candle, the heat flows directly to your finger and it gets burned. That's conduction. Okay? Conduction. Also, heat from the stove transfers to the pan when you are cooking. That's conduction of heat also. Merong direct, no? Kasi direct contact, kumbaga. Example also, ice on your hand melts because heat flows from your hand to the ice. And many more examples. Again, and many more examples. So, pa ka nang mag-plancha mo, okay? Mabita nang mapasok mo sa plancha, no? Kung accidentally lang nakuan, that's already a conduction of heat, no? Kanang, i-try ninyo, ikuan ba? Anong sa bakal na part sa plancha? Try ninyo, di ba? Mapasok mo. That is an example of direct contact, no? That's conduction of heat. Now, let's proceed to the other mechanisms of heat transfer, which is the convection. So, take note, class, that fluids are not considered as good conductors of heat. Again, fluid are not considered as good conductors of heat. Sige daw be, i-try daw og direct contact ang flame sa kalayo. What will happen? Mamatay malamang ang kalayo, di ba? Like example sa kandila, i-direct contact sa water. What will happen to the kandila? It's, di ba, mamatay. Again, fluids are not considered as good conductors of heat. However, sir, giyon sa man pag-init sa tubig, sir, yun sa man siya pag-init sa tubig, they can still transfer heat through the process of convection. Okay, convection. Again, they can still transfer heat through convection. Dili na papasok si convection. Convection is the mechanism of heat transfer that occurs by mass movement of molecules from one place to another. And the movement of fluid produces convection current where it moves in a circular motion from higher to lower temperature regions. Like this one. Okay? Convection occurs when heating water in a pan or heating air in a room. So example tayo sa figure dyan, let us consider heating water in a pan. So as the water in the bottom is being heated, the molecules of the water, it move rapidly and increasing their distance between each other, making it less dense. And once it is less dense, it rises and it replaces the cold water above the pan. And that's the reason why muinit siya. The denser cold water sinks to the bottom of the pan, taking place the warmer water. So the process continues until the water pan reaches its thermal equilibrium. Hangtod mo init, hangtod mo abot og boiling point. Okay? mapansin ninyo class na kadagong mas ma-feeling niyo ang muinit yung mas muinit yung bottom part of the water una before yung top. Pero sir, ngano mo init pagkaabot sa mo init pag pinakalit ang top area of the water? Because again, because of the density of the water, naga-rotate lang man sila. Okay, naga-rotate. So it, of course, pag mag-less dense siya, it rises. So mag-swap sila ang replacing the cold water above the pan or above the caldero. Okay? The denser cold water sinks to the bottom of the pan hangtod siya na po itong mainit. Until the process will continue. Nagatuyo kila sila hangtod maabot og boiling point of water, the thermal equilibrium of this part. So in that figure, this is a convection currents in a pot of water. By the way, convection could either be classified as forced or natural. Again, convection could either be classified as forced or natural. We can say that the convection is forced if it is circulated with the use of blower or pump. For example, air blown by a fan. However, convection is natural or free if it is caused by the density differences due to thermal expansions. For example, when hot air rises. Again, there are two classifications of convection, either forced or natural. Example ng force, yung sa blower, air blown by a fan. An example ng natural or free convection, we have the thermal expansion. That's, by the way, thermal expansion will be discussed next week face-to-face. Again, face-to-face ang discussion ng ating thermal expansion, and there will be a PT for that one also. Now, what are the examples of convection in real life? Boiling water. That's common. The common example of convection, boiling water. So the fluid at the bottom of the kettle is subjected to an increased temperature and becomes less dense. So while the colder, denser fluid on top sinks. Nag-rotate lang na sila. Init, bugnaw, huli, hangtod mag-reach into thermal equilibrium. Second, radiator. So we have also radiator. Cooler air is drawn at the bottom of room while the warmer air is released at the top. Ano sa aircon? Hot coffee with steam. Heat transfers from the coffee to the air above. The hotter, less dense air rises and it's seen as steam. It's a thermohaline circulation, a process affected by both temperature and salinity in the different parts of the ocean. The water at the surface in polar regions becomes very cold and forms ice. And as a consequence, the surrounding water gets saltier and denser and starts to sink. And it travels horizontally below the surface, the sea surface, and it rises when it warmer and become less dense in equatorial oceans. And this process initiates the deep ocean convection currents. Now, the last mechanism of heat transfer. This will be the last mechanism. We're done with conduction and convection. So at this moment, let's discuss the last one, the radiation. So technically, na-discuss naman siya sa chemistry ng definition ng radiation, but let me redefine it also. Radiation is the heat transfer mechanism that could transfer heat even without the presence of matter. This means radiation can transfer heat on an empty space, just like what we are experiencing when we feel the sun's heat. Also, the energy coming from the sun can be transferred even without a medium. And radiation uses electromagnetic waves to transfer the energy from the objects that emit radiation to the object that absorbs it. Just like this one. Okay? Examples of an electromagnetic wave are the visible light. Okay? The visible light and the infrared radiation. Radiation could be emitted with a high temperature, and with that, the object will glow as red hot. If it has a very high temperature, it will glow as white hot. This is because when the temperature increases, the electromagnetic wavelength shifts to shorter value. No, from bluish to white has a shorter wavelength than red. Okay. Now, class, let me give you this, two. Radiation is very important in regulating body's temperature. Why? Because our skin emits electromagnetic radiation to decrease the excess thermal energy in our bodies. So what are some applications of radiation in real life? Ito, we use white or light-colored clothes during summer because it can absorb a smaller amount of heat from the sun to keep us cool. Light-colored clothes reflect light and heat instead of absorbing it. That is why also na kung mag-try mo suot og itom or darker na clothes, di ba mas maka-feel mong igang because gina-absorb man sa mga dark-colored, dark colored clothes ang heat. That is why maka-feel mong igang kung suot mo makanang labaw ng itom nga t-shirt. Okay? So of course, paspas mo maka-feel og igang, it's because gina-absorb na. Pero sa mga light color, just like ang akong gisuot karon, okay? Sa mga light colored clothes, okay? Light colored clothes reflect light and heat instead of absorbing it. Muna, kung i-compare nimo na masuot ka og itom og puti nga t-shirt, mas maka-feel ka og igang kung musuot kag itom kaysa sa puti. Okay? Also ito, the bottom part of the most pans and pots are colored black for them to absorb most of the heat from the stove, thus increasing the temperature faster. Mo tong isa ka reason also, no, wala kanang sa mong balay kay we have this we do not use gasol. But gasol naman din mo ito man siya. So wala kay nila ginapatanggal tong itom na part sa mga pots no or mga kaldero because it will help, mas paspas mag-init ang kaldero pag medyo natong itom sa kaldero na part. Okay? Yung color black ba? O sa tawag, kalimut ko sa term. Basta kanang, wala kalimut ko sa term, basta kanang sa lumot nga part sa kaldero, basta kanang itom, nakalimot ko. Okay? Wala na usually ginatanggal. Wait lang, nag-chat. Wait lang, di na ako makita ang chat kasi nag-chat. Nakalimot ko sa term. Yeah, basta. Okay, wala kay ginatanggal, no, because paspas man mo init, no, ang kaldero or karahay if nato siya. Of course, the water in thermos, okay? Water in thermos gets cold because heat from the hot water inside can still escape through the vacuum. Okay? Ang nagtuo mo nga, kung magbutang mo ininit tubig sa thermos, init na siya forever? No. Again ha, kanang init tubig yung limutang sa thermos, mubugnaw na siya pagkadugayan. Again, because heat from the hot water inside can still escape through the vacuum. nag-chat, no? Pero wala na ako nakita. So that would be all for our discussion this morning about the mechanisms of heat transfer. So to summarize, no, there are three mechanism of heat transfers: the conduction, convection, and the radiation. So easy lang siya to remember. Ang conduction, there is a direct contact, no? Ang convection, kay indirect ang contact. Just like what I mentioned, liquids are not good conductors, no? But there is still a heat transfer through the use of liquid. Meron pa rin naman siya. And radiation is, there is a heat transfer even though there is no presence of matter. That's for radiation. So that concludes our discussion about the mechanism of heat transfer. If you have questions, you can raise right now.